In this very short video, I would just like to discuss how the Python screen and the Python programming language works with a coordinate system. Right? So let's start. In normal mathematics, you might already be familiar with that. And what that says is if I have a point here, P, it is made from two values, this distance here, which we'll call x1, and this distance here, which we'll call y1. So this is how you write a point. Now what's crucial and what Python also keeps is this concept. The first value is always the horizontal axis and the second value is the vertical. Okay, but there is a really crucial and important difference when you deal with Python graphics. With Python, you've got to think of it like this. X still goes across, but Y in the positive direction goes downward. So we've kind of flipped that scale around. So if I have a point here now, P, I measure that distance here, that's my X distance, but this time I measure from this corner, note, the Y distance. So that's that distance there. So when I work in Python, that's how I've shifted the coordinate system to work with. So let's have a look at some very, very simple ideas and what we can do with that very briefly. So imagine, let's rub that out. Imagine we have, let's draw our coordinate system. Okay, so this top left-hand corner is the 0, 0, and numbers get bigger as you go to the right, and numbers go bigger as you go down. Let's say that I have a line here, okay? And I have a point here. So we'll call that P1, and we'll call this line 1. And what I want to do is I want to write some code to make another point reflect directly on the other side of this line, like a mirror. Call it P2, okay? I want to work out how I can get P2. Now this is a very, very simple application of geometry. So let's pick it apart. Let's start by pointing out some basics. The distance from here to here we will call x1, and it would probably help, bear with me a second, if I call this point P2. Okay, now I'll try to explain why I've just done that, but we'll come to it. Okay, that distance there is x1, that's for the line. That's the distance the line is from this corner here. Okay, now the height of the line, we're not interested in this particular example, so just focus on the distance here. Now, when we look at the point, let's use a different color. When we look at the point is this distance, and I'm going to call this x2. Okay, that's why I changed this to a 2 here earlier. So I'm interested in this distance here. So when I click the mouse anywhere over here, there is a distance. Its x value is the distance from that edge of the screen to this point here. Now, two interesting things open up. If I want to then click the mouse and do some code which cleverly works out where this point is, which we'll have to call P3, which you might have spotted but I didn't note down, we have to work out two things. One is, see where the line is, we have to work out what that distance is and flip that distance there. So however far the line goes, we need to add this distance. Remember this distance here, let's use a white, we'll call D. Okay, and clearly if it's a mirror image, the distance of this point to the line is going to be the same for this distance here. So if we can work this out, we just need to use that. And then we'll talk about how we get that point, the distance all the way across. Okay, very first thing to note is, what is that distance? Well, look at the yellow. that covers that whole distance, and this length covers only part of it. So wouldn't it be true to say, if I just use a different colour to draw this out, wouldn't it be true to say that x1, which is this whole length, probably better if I use the same colour so you can follow what I'm saying. Bear with me a second. Right, so x1 equals x2, and let's use white here for the distance, plus distance. Would you agree with that formula? Have a look at the maths on the screen. Okay, that's the distance. I've cut it down there. So basically that plus that gives you that distance. x1 is the sum of that and that. Agree with that formula there? Now, be absolutely sure you're clear how that formula works, because we're going to flip over the page and we're going to work with that formula. So let's quickly redraw our axes. Sketch in the line again, right? Drop in our point and put on the details. That's going to be the new point, okay? That distance we agreed was d, the same as that. We agreed that distance was x2, and we agreed that distance was x1. And the formula we came out with, now run out of space, usefully, let's scrub some of this out to give me some space. The formula we came out with was x1 equals the x2 plus distance. So if I rearrange that formula, I will see that the distance is actually x1 minus x2. Hold that thought. Now, if that's correct, and you need to check you're confident and clear about the mathematics here, if that's correct, then essentially I've worked out that length. If I know those two numbers, I'll plug them in, I'll get it into here. So, how do I locate this x distance here? So let's use another colour. Let's use a green. So what I'm interested in is this distance, which takes us all the way, we'll call it x3, takes us all the way to my new point. I'm going to nickname it P3, just so it's consistent. So what is x3? Well, if you look visually in front of you, x3 is this whole length, but it's actually the same as all of x1 plus d. x3, so x3, the position of this mirror image, is the same as x1 plus, let's use white again, plus d. And that is how you find the distance from here to give you a mirror reflection. It doesn't matter where the line is. The line could be here, the point could be anywhere here. This mathematics will always be correct. So, to summarize, and let's do this with a little bit of red so we can just highlight. That's the first calculation you need to do. You need to work distance. Once you've got that, you can plug that information into there, and using x1, which you already know because it's the distance the line is to that edge, you just add it to that, and that will reflect the point.